Good morning, everyone. So thank you for the introduction, Geoffroy. So let's go together a bit to what FHIR can do for us in a context of operational management. So the key takeaways for today will be focused on people working in hospitals, like data engineers, IT managers, but also people who are more into the business side of operational management. I'm going to give some demos, and in order that everyone is able to understand a bit what is going on in those demos, I will give a very small introduction into FHIR. And the demos will be based on feedback I got from Belgian hospitals and will be aligned to certain Belgian use cases. So if you look into a hospital today, we see the example on the right, the hazel shrub architecture. And that means that there is plenty of software going around, and if you want to make use of management data, it means you have to dig really deep into the architecture to get your data. The new trend we see, at least, is that more and more data is aligned in central repositories, and that makes the use of the data easier for the end applications in the end. Of course, the primary use inward, the original design for FHIR was meant to that, to give a good overview of one patient, of what its medical record is, but also management use, to know what is going on in your hospital and to base yourself, your decisions based on the data that might be available in the central repos like FHIR or SQL or other stuff. And of course, the sharing of data going outward the hospital, and maybe even for some university hospitals who are more into research, they can even have based their OMOP databases based on what is going on in the FHIR repository. My belief is that a FHIR repository, which will be more and more important in the Belgian context because government is asking for data, EHDS will require data that is difficult to dig out of the hospital unless you have some centralized data layer, that the FHIR repo can play an interesting role if you look at the position of an EPD and a data warehouse. So an EPD is very useful if you want to know all details, all clinical data of a patient in real time, but it's not so well in giving you population insights of your EPD. On the other hand, all hospitals in Belgium, they have a data warehouse, and they can analyze whatever is going on in their hospital. But on the backside is that typically those data is 1 day old or a bit older. And there we see a role of the repo, where that the FHIR repo has up-to-date data. You could use that data also to get some operational insights. So before I dive into the demo, let me first give you a very small course on FHIR. So if you look at the structure of FHIR and the data model that is used, then we mostly talk about resources. And what could be a resource? A patient can be a resource, or an encounter with a patient and a doctor. That is also a resource on itself. But typical about FHIR is that all those resources can refer to each other. For instance, an observation refers always to a patient and has been done by a practitioner. So there is a link between observation and patient, and observation and a practitioner. And specific about the FHIR backends is that each resource has a specific URL you can look it for. For instance, you can do a get. If you type in your browser a certain path, you would be able to find, in this case, patient with ID 106. And if you want to limit the number of results, you don't want to receive all the patients, you can use filters, for instance, on certain properties of the resource. In this case, we are only going to filter on the male gender. But as FHIR is referencing from resource to resource, you want to avoid that you need to send a query to your server for each resource separately. So in order to avoid that, there are some extra operations that you can do in FHIR to limit the number of requests that you go to the server with. And an example is the rev include or the include. And let me explain you briefly how that works. Suppose you have a patient, and you know the ID of the patient, but you also want to know all the conditions of that patient, which is a separate resource, and also to get all the observations of the patient. So rather than firing 3 different requests, you could create this request instead. And there you basically say, it's okay, for this patient, I want to reverse include to everything that points to this patient and is a condition, and the same for observation. Another example is the has example. Suppose that you want to receive everything about a patient, but only the conditions that meet a certain SNOMED code, a subject code. That's the only thing I want to say today about FHIR as a language, as a exchange model. Before I dive into the demo, I'll just briefly explain the 3 main architectures that you can use. So the most common, there are 3. One of the most common architecture is the FHIR façade. Basically, if you have your own software and it already has a database, you want to expose that database as a FHIR API. And so rather than copying the data first into a FHIR suitable storage, you could just do a live translation for each request. The main advantage of this architecture is that it's very quick to set up. The disadvantage is that you expose your database almost directly to other software you don't know. So that might be a security issue. Also, if from that software there are a lot of requests coming in, it might jeopardize the original software application because the database might not handle the load of requests anymore. And so the other, but the major drawback of a FHIR façade is that in the long run, it might be very complex to support all different operations into a FHIR façade. So that's why a lot of people and a lot of hospitals start working directly on a FHIR repository. A FHIR repository actually does a translation to FHIR upfront and stores it in a FHIR suitable way, which is a FHIR repository. So the drawback is that you have to copy your data and you have to keep it in sync with the original data. But once it is in there, there is no translation needed anymore. The queries can be handled directly, and typically it's more scalable in the end as a FHIR repo than as a FHIR façade. But the winning combination we see mostly is actually the combination of the two, where you have a façade that has some custom logic that you want to perform, some extra checks, some extra policies you want to do. If you want to expose your FHIR repo also for R&D, there might be some pseudonymization steps that you can all put into an intermediate layer, the façade layer, which contains the custom logic, and in the end, you still use the FHIR repo to store all data. So let me go to a demo to make it a bit more tangible. Just going back a bit for the demo. So we had a clinical overview, very useful. you get a full idea of what is going on with the patient. But if we go to operational management, here we see an overview of what's going on in our hospital. We want to see, okay, how full our departments are. We have in this case, we have 3 departments: cardiology, neurology, and operation room. If I want to know, okay, how do I get this information using FHIR, then we typically request, for instance, a bunch of encounter resources, and the client is smart enough to interpret the FHIR that it can show this diagram. But it still has to request 7 resources. Suppose there would have been a lot of beds, up to 2,000 beds in some of the biggest hospitals in Belgium. This would have required a lot of data. And of course, that is not optimal. We want to limit the data that is sent over the wire and reduce the number of data that goes over it. This was the example where I showed that nevertheless, that FHIR might be not optimal for big diagrams. You can do very cool things with it. This is an overview of the patients that came to the hospital today. Normally, they should be fired out of the hospital by the end of the day, but for some reason, they are still in the hospital, and typically that might be because the doctor is still waiting for some lab investigations that should be done. And in this case, we do that in 3 steps. You could also optimize this into one query using the rev include and the include examples, but basically you request all encounters that are in progress. You're also going to check the open requests for the lab. And then, of course, you need to show the name in the end in the dashboard who is waiting. And the combination of the 3 allows you to give this information in a dashboard. So I'm not going to switch screen anymore. So I'm going to the previous. So the limitations of FHIR are clear. When there is too much, if you use only FHIR for a big diagram, you risk of requesting way too much info of the server, and complex aggregations like a group by in SQL are not possible. And FHIR by design is not suitable for a lot of AI applications. So let me go back to the resource server. So here we have an overview of what is feasible, what are the resources in our repository. And if we want to make use of the flattening of FHIR, I use a utility which is called the FHIR SQL Builder. And basically there I can prepare my data in a way that is usable as a SQL data engineer. And it happens in 3 steps. The first step is that we first are going to analyze whatever is inside of it. And in the second step, we are going to define, okay, what would I like to have as a data engineer to do my work? And basically there I can go, for instance, into patient and looking, okay, whatever is going on here. Because I already did an investigation in the first step, I already got an idea, okay, what are the typical values that I can find in gender? And in this case, I can see that it's only the value female and the value male that is in my repository. Maybe there might be others according to the FHIR spec, I don't know. But these are the values that are actually now here in my repository. So then I could decide, okay, I want to add this to my projection or not. And so here I can do that for a number of resources, the things that I want to put in here. And here on the lower end of my page, you see, okay, what we have put in our projection. A bunch of patient properties, a bunch of observation properties that might be interesting for the demo. So the last step is to, no, we have the projection, we know which FHIR repo we are projecting. Okay, where do you want to have this? So the data engineer needs to define, okay, where will be the SQL where I do it. So I selected the repo we are working on. I've selected the transformation that I just created in step 2. And now I'm going to define the export package. There will be the SQL tables. And also here I could define a user that may access that data. This will be an SQL user. So if all of this is done, then the live reprojection of the FHIR repo will be happening. So it's not a copying of data, it's real reprojection of the data. And so if we go to the SQL part of the data platform, so here are all the tables, and in my package BI, I find a number of tables, and one of them, of course, is patient. If I'm going to execute, select all of patient, we get, for instance, this list. So what do we have? We have the key, the patient per date, the patient gender, family name, given name, and some extra, but also observation. So if we look into what we have copied to observation, what we have selected over there, we get a bunch of data. Now the interesting thing is the data engineer knows how to continue. He has the liberty to create the joins, group bys, sums of, and other type of aggregations with his default tools. And the beauty of it all is that the data itself hasn't been copied again. So let me see what could that mean in the context of a demo. So if we go to the SQL analysis, for instance, if we look into the patient, we are not in this case working with FHIR anymore. So there is a direct JDBC connection with the database to get this data. So here we have a typical statement, a select statement, where we select the gender and the count, and we use that in our overview here. So a lot less data sent over the distribution. Some other typical things, okay, the gender by age and group, also a very easy SQL statement to do that. So here we start using the group bys, the order bys, all things that are very difficult to do in FHIR. In the previous examples, we need to solve this kind of logic in the client. Here, the SQL already does it for us, and the client can be much easier to make. So if we go a step further, we also can do it for the observations. In this case, we want to only analyze the laboratory observations. Again, use a group by. But it's getting more interesting if we are able to join tables together. So suppose that we want to see the typical lab observations by type and gender. It's a basic join in SQL, and that's what we actually see here. We have a select statement where we have the P of the patient table and the O of the observation. We do just a left join between observation and patient. And again, use the group by and order statements. So that's already the power that comes up when your FHIR structure is flattened. You can do the typical joins that the data engineers crave for. But it gets even more interesting when you are going to combine SQL data of data that is not FHIR at all. Suppose that we use invoice data that has nothing to do with FHIR, and also then we can start to do SQL types. So in this case, we are joining invoice tables with the patient data, okay, to know which how many invoices amounts are open, defined by age category. Maybe a stupid example, but at least it gives you an idea. I'm going to go back to my presentation that I've seen. Okay, so the advantages of SQL on FHIR are clear. So the group by operator is by default available once your data is in SQL format, but it's also possible to do joins over different resource types. Difficult to do if you're just working in plain FHIR. And of course, it is possible to have joins between FHIR data and other kind of data. And the main advantage is that your data analyst or data engineer doesn't have to learn a new type of language in order to do that. He can continue to work with his old tool. So now I'm showing the data in the SQL of Iris for Health, but you can connect a Power BI to it. You can connect a Databricks to it if you want. If we go into the Belgian situation, we have the DigiRelab project. The DigiRelab project might be an interesting use case for FHIR repo, and an easy way to start with your first FHIR project and FHIR enablement of your teams in the hospitals. So just to give you an explanation, I've been working a lot in the communication between the hospitals and the doctors and the labs over the past years. And in Belgium, there was always a situation that the hospital or the lab needed to know in what format the doctor wanted to have the lab result. And so it was a lot of administration on the hospital side to set that right. Every time a doctor changed of EPD, there was an issue. They had to call all hospitals and labs to change it. When there was a new doctor switching from one cabinet to another one, a lot of hassle. So the first step in order to solve this problem is that eHealth and INAMI decide, okay, it should be one format. And today, the new formats, they need to be in FHIR. So now all lab should be able to create FHIR bundles. So that's DigiRelab phase 1 and 2. And push that to some medium in the Belgian ecosystem, which is called eHealthBox. And then the doctors are connected to that platform and they can receive the FHIR, and their software should be able to interpret it. So that's the first step. So you could already today catch these FHIR bundles in your hospitals coming from the lab and do operational management on them if you want to. It's a very easy step. In a third step, they are going to go a step further. Then it will be possible for doctors to send a FHIR query to the hospitals, where they not only will request for a specific lab result, but there also will be possible to say, okay, I want the lab results of that specific code, and I want to see the evolution over the last 3 years for whatever you have measured for that specific thing. So in that case, on the side of the lab, there will be a FHIR API needed that is able to respond to these questions. So basically, the lab will need to decide, are you going for the façade, for the repo, or something in between? And that is an ideal example of how you could work with. The examples in my demo also show a bit okay, how that could look like. Show it once again. So the lab observations by type and gender. If you intercept those bundles already being sent through eHealthBox, you could do this analysis already today. So what are the possibilities? First, it's very easy to get the overview of the lab tests and the distribution. And even if the order of a lab is digital, you could also show the average time between order and result. And if you are able to join that with financial data, you could show the impact per type or test, whatever. I'm not a specialist in this part yet, but I'm sure that you guys, the girls, have plenty of ideas what could be possible over there. So I know a lot of the hospitals are not working with FHIR a lot themselves today. It doesn't mean that there is not FHIR going around in the hospital, but typically if you want to get involved as a hospital with FHIR, the first step is, okay, to build up knowledge. And if you have your first proof of concept, always start with read-only projects where you do not push data into the FHIR repository. I'm going to go a bit quicker because I'm a bit out of time. What is important about our technology is that we offer the FHIR repo, but also the technology to do the reprojection to do the FHIR to SQL, and also to host data that is not in FHIR format, to have whatever of type of data and host it into FHIR. I didn't talk much about Smart on FHIR today. That's about security and avoiding that everyone can request any kind of data in your repository. Those are all basic features that each FHIR repo needs to have. If you're still making a decision on what should I choose, make sure that whatever you choose, that the 3 FHIR architectures are possible and that auditing and resource validation is present. That's the basic of FHIR. If you are going to go more to production, you should be aware of scalability. You want to avoid the situation that you start today with the technology and that later on you start doing performance tests and then you need to decide, okay, we need to switch. So do the scalability tests in an early stage. And if you're talking about production, okay, you need to think about how do I make this available in a high availability mode? Can I host multiple FHIR repositories in one instance or not? How will backup techniques work? And if you want to do some unique features we offer is of course a FHIR to SQL, but we also have a FHIR to OMOP pipeline, and you can, if you're working with the hybrid model, you can also add custom logics in Python in that intermediary layer. So before I go dive into the questions, the conclusions I would like to make today is that that FHIR repos can serve in some conditions for operational management cases. And using the new AI coding tools, the front-end creation for FHIR is more doable than ever before. So in general, I would like to make the statement that FHIR backbones allow to shift control more and more to the hospital IT departments, and that in the end it will accelerate the innovation inside the hospitals itself. Let me go to the team chat now. So are there questions? I'm going to show the last slides. If you want to explore yourself what is in our FHIR repo, there is a free InterSystems Iris community version. You can download it as a container, but also as a plain install kit. And if you want to play with the demo that I've given today, just give me a little mail and I will share my GitHub repo. Okay, they say there is one question. Okay, let me see the questions. So, okay, how can I make sure that my repository is only showing the things that it's allowed to show? So that's a good question. If we go back to that's typically something that is solved with Smart on FHIR. In Smart on FHIR, it's a layer that you can activate on your FHIR repo, where you collaborate with a third system that will tell you, okay, what that user that is trying to access that data is allowed to see on your FHIR repo. So that's a way to avoid it. Are there other questions? Okay, I have seen what about auditing? So indeed, a very good question. We're dealing with very sensitive data. If we want to know who requested that data, auditing techniques are the basic for a FHIR repository to have. So this is done by default. So each request that comes in, we store the requester that has asked the data. So that's it for the questions now. If there are no more questions anymore, I would like to conclude this this seminar. If you want to connect with me, send me a mail or on LinkedIn. If you say, okay, I feel a bit uncomfortable to start with this in my hospital, give us a shout. We're happy to help you to put your first steps in the FHIR world. And basically, that's it.
And we send you the slides.
And we send you the slides after this event. Thank you for your presence and have a wonderful day. Thank you.